Let's explore one of the most important packages in Python, Pandas. Pandas is where Python started getting traction from the data science community. It provided one of the most intuitive interfaces to handle and manipulate data. Pandas is essentially built up from two parts, series and data frame. Series is a one-dimensional labeled array capable of holding any data type. You can see a sample Pandas series over here with 8 rows and an associated index. A data frame is a two-dimensional labeled data structure with columns of potentially different types. But this is analogous to the Excel spreadsheets or SQL table. Over here, we can see that the rows have an index as well as the columns have a column index. Now we can access one of these elements with the row index and the column index. Now this, unlike other data types, can have numeric values or even string values. We can alter the index values as per our convenience. Now to note, the series is the data structure for a single column. So essentially, the data in a data frame is actually stored in memory as a collection of series. So technically, data frame is built on the foundation of series. Let's look at Pandas from a deeper perspective. This being one of the most important packages for our data engineering and feature engineering activities, we'll spend a little extra time on this, figuring out what all does the package offer. So to get started, let's have a sample dataset from the internet. I would request you to download this dataset, which is an HR analytics dataset from Kaggle. It's freely available and it's around 500 KB in size. If you go to this link, it will take you to the Kaggle website. Please create an account over here and download this dataset. I have already downloaded this dataset and kept it ready for the analysis. So I'll just copy the path and come back to Spider. To load data into the memory, we'll first need to import the package Pandas. Pandas as PD. Once we load the package into the memory, we need an interface to load the CSV file from the hard drive into the memory. Now, Pandas offers a variety of interfaces to load different types of files. It could be a CSV file, it could be a JSON file, it could be an HTML file, and probably anything else. Since this is a very simple exercise and I've kept the external dataset a simple CSV file, our task right now will be very straightforward. We'll create a variable called df, which can be called as data frame, and we invoke the pandas function to load the data. So we say pd dot read, and you can see a variety of options have actually opened up. So let's take the simple one, pd dot read csv, and then we pass the path for the file. Now, since this is a Windows system, I would like to point out one additional thing. The forward slashes over here will not actually work with Python. You would actually need to use a Linux compatible version slashes. So if in case you're planning to use the forward slashes, you need to use an escape character. So essentially, had you been using the forward slashes, you would have need to use an escape character, and then you could have leveraged that. Or you can use a Linux-based convention to load the data into memory. So I'm accustomed to the Linux-based type. Now let's just copy the file name and load this into memory over here. Now, there are a couple of extra parameters over here, which I'm ignoring for the time being. Now, since this is a very clean and neat data set, we don't need to pass in additional parameters to get the data in the right format. Let's load the data. Now, as you can see, the data has loaded into memory into this data frame, df. You can see that it has approximately 15,000 rows and 10 columns. Let's check the data type. So what type is of data frame? Yes, you see it's a data frame from Pandas code. Now to understand the data more, the first step we'll take is we'll explore the length and the breadth. We'll technically look what is the size of the data set. So Pandas provides a simple property called shape. Using the shape operator, we can actually check the dimension of the data frame. So as we know already, it has a dimension of 14999 and 10 columns. So what are the different columns in this? So we know there are 14999 rows, but we're probably interested in know what are the different columns present. If you just want to know what are the column names, you can just use the column property. So df.columns gives us a list of actually all the columns in the data frame. Now, we understand that there is satisfaction level, last evaluation, number project. A lot of HR related attributes are listed over here. But then what values have actually been stored in these different columns? So to get a sneak peek of the entire data set, we can just look into the first 5 rows of the entire data frame. So if you are familiar with the Linux or Unix environment, you can just use a head command. So if I say df.head, and I pass in a number of, which will be the number of rows that we will return. So I'll say give the first 5 rows of the entire data set. So that is df.head of 5. So I can actually see 5 rows of each column in the data frame. So it tells me that, okay, the satisfaction level, I can see values like 0.38, 0.8, 0.11, and so on. I presume the values will be between the number 0 and 1. A similar story for last evaluation. Number of projects should ideally be a distinct number of projects the employee has been associated during the stint with the company. Average monthly hours should be the number of hours he has clocked in for the company. Time spent with the company should be number of years. Work accident should definitely be a flag. Left should also be a flag to indicate whether he is still associated with the company, and so on. We see 2 categorical variables where we have sales, and the value sales, and probably a couple of more values. We don't know what are they yet. This should probably be an indicator of what department the employee is associated with right now. And then salary, indicating as low, medium, or probably even high. We'll explore this further, but then let's take a look at the bottom 5 rows. Probably it might give us a better perspective. So instead of df.head, I'll see df.tail and explore the last 5 rows. And we can see that, yeah, sales has the value support also. So this is most probably an indicator for which department the employee is associated with. And then similar values for which we have seen in the previous columns. To understand whether these columns have any other values like null values or missing values, let's use the command info. So info is a function provided for a data frame to see a high-level view of the entire data set. And here we go. We get information that the range index has 1499 entries and ranges from 0 to 14998. We can see that there are 10 columns and each of them have no null values. Just for example, 14999 non-null values. And this would be the data type for the respective column names. So we have float 64, N64, and then object. Object is basically a string object. And we can also see how much memory does this object use. But this gives us a very high level view about the object. But what if we want to know something about the entire data set in terms of summary statistics? There is another function called as describe, which actually gives us a high level sneak peek with additional details on all the numeric columns. So if we have a look over here, we can see for satisfaction level, which is one of the columns in the data frame, we have the count, the mean value, standard deviation, and the percentile distribution, which is min, 25, 50, and 70 percentile, and the maximum value, which is the 100 percentile. This gives us a better view of the entire data set. And as per as our previous understanding, we do understand that the values are between 0 and 1, and probably almost the same with last evaluation. Though we don't have 0, we do have a min close to it, and we don't see the values exceeding 1. Number of projects generally has a mean of 3.8 and has a maximum of 7. And with this same function, we can actually get a sneak peek into the other columns. What is missing over here is the categorical columns, or the columns which are the string value. That in this scenario would be sales and salary, right? We'll explore sales and salary, the categorical variables, in more detail later on.